There's a man with a broken arm, a fused knee, and likely one good eye standing at the edge of a cave in what is now northern Iraq. He is carrying a body that should have killed him years ago. He didn't die. And that fact, that single quiet fact, is the door into one of the most extraordinary stories in the history of the human species. His name, as scientists gave it, is Shanidar 1. He was found in a cave in Iraqi Kurdistan, excavated in the 1950s by a man named Ralph Selecki. And from the moment researchers got close to those bones, something was wrong, in the best possible way. His right arm was withered, probably useless from early in life. His left knee was fused. His left eye socket showed trauma. He may have been partially blind on that side. And his ears, this is where it gets strange, showed heavy bone growths from years of exposure to cold air or cold water. He was likely hard of hearing, maybe more than that. Now think about what that means. This is a Neanderthal who could barely use one arm, walked with difficulty, couldn't see properly, couldn't hear properly, in a world where you hunt to eat or you don't eat. In a world where falling behind means dying. He didn't fall behind. Eric Trinkhaus at Washington University in St. Louis and Sébastien Villot at the University of Bordeaux analyzed these exact injuries and published their findings in 2017. Their conclusion was simple and quietly devastating. This individual survived long after those injuries should have ended him. Not weeks, years, possibly decades. That doesn't happen alone. Someone fed him. Someone kept him warm. Someone in that group decided that this broken, impaired person was worth keeping alive. And that changes the image completely. These weren't mindless creatures driven only by strength. They were a community. And the community held. But here's where the story opens up. Because the care tells us something about who they were. The body tells us something else entirely. About what they were built to do. If you've ever wanted to understand where the human body's real limits come from, subscribe now, because what we cover on this channel goes much deeper than one skeleton in a cave. Before we go any further, I want to know something about you. Drop in the comments. What region does your family trace back to? Just a country, a general area, anything. Because by the end of this video, you're going to see why where your ancestors lived might be more connected to this story than you'd expect. Now, back to the body. The injuries tell you what went wrong. To understand what Neanderthals were actually capable of, you need to look at what went right. And what went right starts with the chest. In 2018, a researcher named Daniel Garcia Martinez at the University of Alcalá in Spain led a team that did something nobody had done before with this level of precision. They reconstructed a full Neanderthal ribcage, not from one skeleton, but by carefully combining measurements from multiple specimens to build the most accurate model possible. They wanted to know how these people breathed. What they found was not what people expected. The chest wasn't just bigger, it was shaped differently, lower, wider at the bottom. And the ribs flared out in a way that created significantly more room for the diaphragm, the main muscle that powers breathing. And when they calculated what that shape would mean for lung capacity, the number came back at roughly 20% greater than a modern human of the same body size. 20%. Not a rounding error, not a small margin. 20% more air moving through the body with every single breath. Think about what that does in practice. More oxygen reaching the muscles. More endurance when every breath in sub-zero air costs energy just to warm before it reaches the lungs. A body that could sustain real physical effort, carrying, climbing, close-range hunting in conditions that would have modern humans slowing down and gasping inside the first hour. And yet the data said the exact opposite of what the simple story claims. Because this wasn't about sprinting. This wasn't about a quick burst of explosive power. This was about a chest built for sustained effort in cold, heavy, unforgiving environments. A body tuned, over hundreds of thousands of years, to one specific kind of world. That precision matters, and it takes us somewhere most videos about this topic refuse to go. Stay with me, because this next part is the reason this video exists, and it's the part most channels either don't know or don't want to say out loud. There is a large gap between what the science actually shows and what gets written in thumbnails. If you care about this topic, really care, You deserve to know exactly where that line is. In 2024, a team led by Leonardo Iasi at the Max Planck Institute for Evolutionary Anthropology in Germany published one of the most detailed analyses ever done on Neanderthal ancestry in modern humans. They didn't study one genome or one population. They looked at ancient and present-day genomes together to map when and how Neanderthal DNA entered our species. What they found was precise. Most of the Neanderthal ancestry that non-African people carry today traces back to a shared window of contact between 50,000 and 43,000 years ago. A real datable moment, not legend, not estimate, genomic data. After that contact, selection happened fast. Some Neanderthal variants in the modern human genome were kept. Others disappeared rapidly. The ones that stayed were there for a reason. They worked. The ones that vanished caused problems in the new hybrid biology and were removed. Now, I want to be direct with you because you can handle the honest version. There are videos, a lot of them, that tell you a specific Neanderthal gene is the reason some athletes today are faster or stronger. That story is clean. It sounds true. But a single confirmed Neanderthal-derived athletic performance gene directly powering modern sprinters? The evidence for that specific claim is weaker than the story built on top of it. And I'm not going to tell you something is proven when it isn't. What is proven is different, and actually more extraordinary. Neanderthal DNA is in your genome if your ancestry traces outside sub-Saharan Africa. So researchers have confirmed that Neanderthal variants specifically boosted innate immunity, the first-line defense against infection. Luis Quintana Murci at the Institut Pasteur in Paris found that innate immunity genes carry higher levels of Neanderthal ancestry than almost anywhere else in the coding genome. That's not a theory. That's confirmed through multiple independent studies. When our ancestors met Neanderthals and interbred, they walked away with a stronger immune system for the pathogens they were about to encounter across Eurasia. And there's more. Filip Kadovich at the Max Planck Institute for Evolutionary Anthropology found that genes involved in lipid catabolism, the way the body breaks down fats for energy, are 3 times more enriched with Neanderthal variants in Europeans than in other populations. Those variants show signs of recent positive selection, meaning they helped. The body kept them because they worked. In cold climates, fat metabolism is survival. Everything I just told you, hold on to it, because it's about to mean something completely different when we look at the parts that didn't survive. Most people, when they think about inherited DNA, think about what's there, what came through, what got passed down. But some of the most important information in any genome is in what's missing. Geneticists call them introgression deserts. These are regions of the modern human genome where Neanderthal DNA is consistently, almost entirely absent. Not in one person, not in one population, but across thousands of people from different continents with different ancestries, the same regions, empty. In 2024, a large study analyzed over 30,000 people with mixed ancestry to track exactly where Neanderthal DNA had survived and where it hadn't. What they found barely made it out of specialist circles. These desert zones were clustered near genes connected to reproductive processes. The Neanderthal variants that caused the most problems in hybrid offspring were removed first, fastest. The body recognized the incompatibility and over generations corrected it. This was made public recently. Almost nobody talked about it. Until now. What this tells us, carefully, without overreaching, is that the collision between our two species left a record of what worked and what didn't, written directly into living human DNA. The deserts are not nothing. They are the shape of a biological negotiation that took thousands of years to settle. So yeah, actually, real quick, if you watched my last video on Cherokee DNA and the origins that scientists completely didn't expect, you already saw this pattern once. That story was also about absence as much as presence, about what's missing from the genome telling you as much as what's there. Did that video change how you think about ancestry and the claims people make about it? Tell me in the comments. And if you haven't watched it yet, it's linked right here. It connects directly to what we're covering today. Now, let's do something most documentaries don't do. Let's put the title of this video on trial. Neanderthals were the strongest humans ever. Is that true, exactly as written? The honest answer is, not exactly. And here's why that actually matters. No serious peer-reviewed paper uses those words as a conclusion. Yet what the research shows is more specific. Their skeletons were robust, their bones were dense, their chests were built for sustained cold weather effort. Their communities kept injured individuals alive for years. Those are real, documented, supported findings. But Daniel Garcia Martinez, the researcher who rebuilt that rib cage, was precise about what his study showed and what it didn't. It showed greater lung capacity. It showed a chest built for a different kind of breathing. It did not declare a winner across all of human evolutionary history. Here's the thing, strength is not a single number. A Neanderthal body tuned for close-range hunting in sub-zero conditions is not the same as a body built for endurance running in equatorial heat. They were not strongest at everything. Say they were extraordinarily specialized, optimized for a world that no longer exists, in environments that most modern humans would not survive without shelter and technology. What you can honestly say, and what holds up under scrutiny, is this. Neanderthals had remarkable physical architecture, built by conditions more extreme than most humans today ever face. Their bodies were shaped by 300,000 years of ice and pressure and cold. That's not a small thing. That's an almost incomprehensible depth of biological refinement, and some trace of that inheritance, in immune function, in metabolic adaptation, in ways researchers are still identifying, is present in people alive today. That's the real story, and it's more powerful than the shortcut. There's a cave in central Germany called Ranis. It doesn't make headlines often. But in 2024, it became one of the most important sites in the world for understanding what the relationship between modern humans and Neanderthals actually looked like. Researchers from a collaboration involving the Max Planck Institute and the Francis Crick Institute analyzed ancient DNA from some of the earliest modern humans found in Europe. And what they found rewrote the timeline in a single result. These early modern humans, buried at Ranis over 40,000 years ago, already carried Neanderthal ancestry. Not a trace. Enough to date it back roughly 80 generations before they arrived in Germany. 80 generations. If you count 25 years to a generation, that's 2,000 years of mixed ancestry already in place before these people crossed into Europe. Saying the meeting between our species wasn't a single event at the edge of the continent. It happened earlier, deeper, somewhere we haven't fully located yet. What they found next changed the framing entirely, not because it added new data about Neanderthal strength, but because it removed the last comfortable distance between us and them. They weren't alien. They weren't monsters. They weren't a separate chapter in a different book. They were close enough to our ancestors, similar enough biologically, compatible enough reproductively, that they left descendants who are walking around today, whose children's children's children stood in a German cave more than 40,000 years ago, already carrying two lineages in a single body. This isn't ancient history in the sense of being removed from you. This is in the physical inheritance of every person alive today whose ancestry traces outside sub-Saharan Africa. It's in immunity. It's in how the body handles fat in cold climates. It's in ways we're still learning to read. Now, let's talk about what survived selection, because this is where the story stops being about ancient bones and starts being about a process that is still written into living human biology. When Neanderthal DNA entered the modern human genome 50,000 years ago, it didn't just sit there. Natural selection looked at those archaic variants and made decisions across thousands of years. Keep this, remove that. This one works, that one causes problems. Priya Morjani at UC Berkeley led the work on this timing. Her team's 2024 analysis in Science showed that selection on Neanderthal variants, both keeping and removing, happened rapidly after admixture, not over millions of years. Within a few thousand years of the mixing, the genome was already reorganizing. What survived isn't one gene. It's distributed across multiple systems, immunity, as we've already established, where the evidence is strong and confirmed. Lipid metabolism, where Neanderthal variants are specifically enriched in European populations and show signs of positive selection. And sugar metabolism. Researchers found that Neanderthal DNA sequences modified gene activity in response to changes in blood sugar regulation. Even stress hormone response has a Neanderthal signature in some living people. A 2023 study using data from nearly 300,000 people found over 4,000 Neanderthal-derived genetic variants that are still actively influencing 47 distinct traits in modern humans today, including how fast someone burns calories and how their immune system resists certain diseases. 4,000 variants, 47 traits, still active, right now. Stay with me, because here is what all of that adds up to. The most viral story about Neanderthals says one strong gene made them the strongest humans ever, and it's still in your muscles today. That's a clean story. But the real story is messier, wider, and more extraordinary. The Neanderthal contribution to modern biology is spread across hundreds of small decisions made at the cellular level over thousands of years. Immunity, fat breakdown, stress response, sugar metabolism. A distributed inheritance from a population that spent 300,000 years figuring out how to stay alive in environments that should have killed them. You can't point to one gene and say that's their strength in you. But you can say this: the parts of you that handle cold, that fight infection, that regulate energy in low light, low temperature conditions, those parts of your biology carry traces of a people who lived those conditions longer than any other human lineage ever has. Let's come back to where we started. A bone under cold light. A man who survived injuries that should have ended him. A chest built for air no one living today needs to breathe. A genome mixed with ours 50,000 years ago that is still being sorted, still being understood, still giving up its secrets, one study at a time. What do we actually know? Their skeletons were robust. That's in the physical record. Their lung capacity was greater. That's in Garcia Martinez's ribcage data. They survived severe trauma inside functioning communities. That's Trinkhaus and Villot. Their DNA entered our species in a real datable window. That's Ayasi and Morjani. And thousands of their genetic variants are still active in living humans, shaping immunity, metabolism, and other traits. That's confirmed across multiple independent research groups. What gets cut from the honest version, strongest ever, as a ranked, universal, scientific conclusion? That's a story. The evidence is more specific than that, and more interesting. Because what these people actually were, not the cartoon, thus not the shortcut, is something that took 300,000 years of extreme conditions to build. A lineage shaped by ice and cold and pressure. A species that buried their injured, fed their disabled, breathed differently than we do, and left a biological inheritance that is still being discovered today. I want to be clear about something before we reach the final line. This is a story about physical ancestry, migration, and ancient biology. That's the scientific lens, and it's the only lens being used here. It says nothing about human worth, human dignity, or the beliefs that shape how we understand our place in creation. Those are different questions, and they belong to a different kind of conversation. What genetics offers is narrower than that, and in its own way, just as profound. When it tells us that the line between them and us was never as clean as we thought, that the species we call extinct left something real inside the living, that what they endured, the cold, the weight, the slow collision with the people who looked almost like them, left a mark that 50,000 years have not erased. The fossil is gone. The world that built it is gone. Some of what that world made is not.